Good evening, all. This is this Dr. Praveen, Associate Professor, CS and A, SR University. Now, today we will discussing regarding pointers in C language. Pointers in C language. What is the main objective of pointers? Why we learn the pointers in C language? And one more concepts of how the pointers are using with arrays and how the pointers are working with functions as well as structure, and what is pointer to pointer and what is pointer to string. These are the main concepts in the pointers, right? Now, this is my mail ID, p.praveen.sru.edu, and my mobile number 9885401731, right? Now, the concept is the pointers. Concept is pointers. Now, first, what is pointer? Why we learn this pointer? Okay, in every video, I followed one method. First, we learn the definition, we discuss the definition, and another one is the syntax. And here there is no pictorial representation. Actually, in our previous all concepts, we discussed the pictorial representation like flowchart, but here there is no specific flowchart. And example 1, example 2 with the test cases and a description of the concept. This is the methodology I followed in every video. So now the pointer, what is the pointer? See, now pointer is a variable. Pointer is a variable which stores the address of another variable. See, observe here. Pointer is a variable. What is the variable? Variable is a small part in our program. It is a small unit in the program which stores some value. Right now we declare it as type variable. Type variable. What is the type? Here we take int a. Int a. When we declare this variable, the 4 bytes of memory is allotted for a. That address is, for example, we assume 4002. Just we are assume 4002. Now this is the name of the variable. Name of the variable. And this is the value of the variable. And this is the address of the variable. Address of the variable. So now this is a normal variable. Now what is pointer? Pointer is a variable which stores the address of another variable. Observe here, pointer is a variable. So this is a is a normal variable. Now pointer is a variable, so which contains some data type, right? Always this data type is integer, sometimes integer. Yeah, int a. Int a. Right? Now this is normal variable. Now pointer variable is always preceded with the asterisk symbol. We declare like this. The compiler easily understand whether the variable is a normal variable or pointer variable. If it is normal variable which stores value, which allows the value. If that variable is a pointer variable, it doesn't allow the value. You remember the difference between normal variable and pointer variable. If the variable is normal variable, which allows the value, like now what is the variable? A is a normal variable. I want to take 10. 10 is the value. So this will be allowed. So now a value equal to 10. Okay, this is valid. Now the coming to pointer. Pointer is a variable which stores the address of the another variable. When we are declare star p, it take the star p. P is a variable. That address is, for example, 5024 PSM. Name of the variable is P. Address of the variable is 5024. What is the value of the variable? What is the value of the variable? Now coming to definition. Go to definition. Pointer is a variable which stores, okay, which stores address of another variable. So now what is the value of the P? Which contains some addresses, not value. For example, I want to take 20. It is the invalid. It is not allowed. It doesn't allow the 20. Now, instead of 20, we take the address. Now, how can we represent, how can you denote the address of the variable? By using the operator, that is ampersand A. P is a pointer. Pointer is a variable which stores the address of another variable. What is ampersand A? 4002. 4002 is assigned here. This is the basic definition of pointer. I think everyone understand this concept. Now go to the pointers. Pointers, introduction to pointer. I think it is visible to all. Second. Every variable in C language has a name, a value associated with it. Associated with the name. What is the name of the variable? What is the name of the variable? Name of the variable is, sorry, name of the variable is, we take, name of the variable is A. Name of the variable A. The value, value of the variable is 10. Okay, already we declared. Now when you are declare A, name is A, address is 4002 and value equal to 10. Value equal to 10. Then a variable is declared, a specific block of memory in the computer is allocated. What is the specific block? Now this is the specific block of the memory. 4002. Directly it is not 4002. Actually addresses are almost 8 bits. Okay, 8 integers. I will show the addresses also. Don't worry. And the size of the allocated block depends on the type of the data type. Now here we declare the integer. Say integer int A. Now what is the size of the integer? 4 bytes. Now bits of memory is allotted for A. The statement executed, the compiler sets 2 bytes to 4, 8 bytes of memory to hold the value 10. This is the introduction to pointer. Okay, now normal variable. We discussed normal variable. Variable's address is the first byte occupied by the variable. Like 4002. 4002 is the first byte. Now coming to pointer. Now go to the definition. Pointer is a variable of the rear. Pointer is a variable that contains the address of another variable. That contains address of another variable, declaring pointer type. How can we declare the pointer type? This is the first part. Now, when we are declaring the pointer, the asterisk symbol is must. So remember this point. Now, int, like int, data type is int, star, star, int, ptr, star ptr. Okay, star ptr. One second. Here we declare the data type star PTR name. Data type star PTR name. Okay, now star is indicate the this variable is not a normal variable. This is the pointer variable. You observe here. This is not a normal variable. This variable is the pointer variable. Now, what are the data types we have? We have different data types. That is called, these are all the data types. These are all the data types. Now, the following variable which contain variable names are A, B, C. Now, every variable preceded with the star symbol. So, the star symbol is nothing but a pointer variable. That is called asterisk. When used as above in the declaration, tells the compiler that the variable is to be a pointer. And the type of the data that the pointers pointing the data is the star symbol. So star here we take two symbols. One is the star symbol, another one is the ampersand symbol. Okay, star is indicate the value, right? Ampersand indicate the address. Next we will discuss these two. Now coming to this one, data declaration type integer identifier. Identifier is the name of the variable. Pointer declaration type star. We take one extra symbol here. Here this is int a. Here this is int star a. Now a is a variable, normal variable. Star a is the pointer variable. That is the difference. Yeah. Now almost we have different variables are there. Star a. Star a is that is the character star a. So this is the pointer int n. So this is assigned 15. Float x. This is also normal variable 3.3. Character star p. So now this is the pointer variable int star q. This is a pointer variable. Float star r. This is a pointer variable. So now star p equal to, for example, I want to take n. Star p equal to n, right? And p equal to what is it? It's directly we are not allowed the value to the variable, because in our definition pointer is variable which stores the address of the another variable. Okay, now coming to next one. A variable name directly refers to a value. A pointer indirectly references a value. Variable directly reference means 10 is assigned to a directly. Now reference, indirectly reference means p equal to ampersand a. Now p equal to ampersand a. Star p equal to nothing but a. Both side we take the star symbol, automatically star of ampersand a is normal. I will show the example. Referencing a value through a pointer is called the indirection. Indirection. And ampersand address operator which gives or produces the memory addresses of a data variable. So already we discussed, we have a two symbols. One is the ampersand symbol, another one is the star symbol. Ampersand symbol is represent the address operator. Star symbol is dereferencing operator. Dereferencing means which extract the value from the location. Okay, now p equal to ampersand here. So what is, how can we extract the value from the p? Now I will show. Here, take two variables. One is pointer, another one is normal variable. I will show. Into data type 10. When we declared this one, a address is 4002. We just take this one 10. And I want to take one more variable, star ptr. See, now we create a ptr. Now the address is 5024. Clear? Now a is a normal variable, star ptr is the pointer, and I want to take here ptr equal to ampersand a, because pointer is a variable which stores the address of another variable. So a address is, what is the address? Now this is address 4000. 4002 is assigned to PTR. Now this value is nothing but a 4002. 4002 is assigned to PTR. Suppose if you want to extract the value from the 4002, then I want to take like this PTR equal to ampersand A. Observe here, both side I want to take the star symbol. Both side I want to take the star symbol. Now what is ampersand A? Ampersand A is the 4002. Now star of 4002, observe here, star of 4000 which provides the contents in the memory location specified by a pointer. 4002, this is the address. Star means value from that address. Star indicates the value or contents in the memory location. 4002 is the location. Now what is the content in 4002? That is 10. So what do you mean by here? Star p equal to what is the value? Now this is the dereferencing operator. What is the address operator? Another one is the dereferencing operator. I think everyone follows pointer. It is very easy as well as complex concept in our C language. But as maximum, most of the people scared about this concept, but it is a very easy concept. Just you can understand what is pointer, what is normal variable. Okay, why we are assigned the value to the pointer? So simple. This is the dereferencing. Dereferencing means indirectly we print the value. Indirectly, when we know the address down, then the directly the control is move to that location and extract that values. So now this is ampersand inverse star. I think you understand this one. Now ampersand inverse star means now star A ampersand A. Star is something equal to ampersand here. Now here already there int x equal to 10 star PTR equal to ampersand x. Now PTR already we discussed. PTR equal to ampersand x. What do you mean by ampersand x? Address of the x. Address of the x is assigned to PTR, and we extract that value from that address. Then we should use the star informs the compiler that PTR is a pointer variable, and the int specifies that it will store the address of the integer variable. So L value, left value is assigned to the right side variable. Now here we have steps when we write PTR equal to ampersand x. So the 1000 already we discussed. 1003 is assigned to PTR. If you get value from the 1003, so simple we are use PTR equal to ampersand x. Both side I want to take the star symbol. So the x equal to 1003 star 1003 means that value is a 10. We extract the value from the for 1003. So this is the simple pointer initialization pointers concept. Now next we move to the initialization. Right. Yes, now here how to initialize the pointers. See, already we discussed pointers. That is a pointer is a variable which stores the address of another variable. Right. Now the pointer always declared with the asterisk symbol. Now asterisk symbol. Now see this example int star p comma n. N is a normal variable. P star p is the pointer variable. So p equal to ampersand n. P equal to ampersand n. So p equal to ampersand n. It indicates the address of n. Address of n some for example 4000, that 4000 is assigned to the variable pointer variable. We declare it like this in memory management. When we declare these two variables, we created two variables. One is N, another one is P. Now this is the address we assume 4000. This is the address of the pointer 5000. So now variable name is P, address of the variable is 5000, right? N, address of variable is 4000. So now what are the values here? Some default values are there. P equal to ampersand n. Now what is ampersand n? Ampersand means address of the n, address of the variable. So ampersand n equal to 4000. P means P equal to 4000. So P equal to 4000 means here we have a address. So the value of P equal to 4000. It means the connection established between P and N, right? This is the normal declaration. Now we want to take the other declarations. The data type of the pointer variable and the variable to which points must be the same. You observe here. Now pointer variable is integer. The variable name is also normal variables. Both are must be the same data type. Now here the example is into star p. The pointer is integer, comma n. N is the variable, normal variable. That is also belongs to pointer. Float x. Observe here. Now float x. Now these are the different integer float. P equal to ampersand n. P is integer. N is also integer. Now the both must be the same data type. So this expression, the statement is valid statement. Coming to next statement, ampersand x is assigned to the pointer. What do you mean by ampersand x? Now ampersand x is a float data type. Okay, ampersand x, so this is the integer data type. Now float data type is assigned to the integer data type. It is wrong. So actually you observe here this integer, this float. Now is it both are equivalent? Both are must be the same? No, absolutely wrong. So this is invalid statement. Okay. Now valid statement means now the pointer variable and normal variable, these two variables must be the same data type. Right? Invalid means the pointer variable is different from the normal variable. Right? Coming to how to access the variables. The ampersand operator preceding the variable returns the address of the variable associated with it. So you know the ampersand operator, like you take the ampersand to n is assigned to p. Ampersand n is assigned to the p. Now the following are illegal use of address operator. Ampersand value is wrong. And next, int a of 10 comma ampersand a references a complete array. Ampersand x plus y, this is also illegal, invalid statement. Now these statements are not correct. So now how to access the element? The int star p ampersand a. This is the valid because p is a pointer variable, a is the normal variable. Now before this, how can we declare int star p declaration? Initialization, now ampersand a is assigned to the p. You observe here, when we are declare int star e comma a, comma a. Now we are assigned some value, 10 is assigned to a. So the variable is a, the other variable pointer variable is p. Now a address is 4000, address is 5000, right? Now value of a equal to 10, value of p is empty. Now when we are take this statement, ampersand a is assigned to the pointer, so the link is established between pointer variable and normal variable. This is the assignment. And next, assignment. This is also illegal. You observe here. Int star p is the illegal. Now instead of star pointer equal to 1000 is illegal. So why it is illegal? Here we should take the variable because in already pointer definition, pointer is a variable which stores the address of another variable. So here it required another variable. So n is another variable. Now you are directly we are not assigned n. Address of n ampersand n is assigned to ptr. This is the correct implementation. Yeah, now coming to one example here. Now, I think everyone knows the structure of C program. First, we have to write the program name and developer name, that is your name, and date of execution. And always your program starts with hash symbol, hash include stdio.h. We have to including the header files in our program. And int main, so why we are using int here? And sometimes we have to use the void also. So the return type of the variable function, either void or integer. Now, if you are take integer, then you should, there is no return value, then simply you take the return 0. If you take void, there is no need to return any value. That is the difference. Now, local variable declaration. What are the local variables? A is normal variable, A is a local variable. P is a pointer variable. Now A equal to 10, A equal to 14. So 14 is assigned to A. And P equal to ampersand A. What do you mean by P? Now P, some address is there, like suppose 13, right, 680. Yes, 680. That is the address of P. Now what is the value of P? P ampersand A is assigned to B. So this address, here, this address is assigned to this block. So you print A, that is normal variable. You print ampersand A, it will return the 135760. And now printing the values, print percentage D, P. P is a, what is the value of P? 13 something. Star P is the value of, and A is the value like 14. So now P and address, that is called, and one more is the address again. Now the result is 14, 14. Star P is 14. A is also 14. And P is address of the variable. And before that, we have some A and ampersand A. A is a value. What is the value? 40. And ampersand A, 135760. This is the simple example of pointer. Okay, here we have one more example. So now you print the addresses as well as values. I want to take one example here. When we are declare the first line, now A, N, observe here, all of you look carefully. Value of N equal to 10. Now take the assumed address 4000. Right? And you declare one more variable like that is called the pointer. Now the address is 5000. Okay, that is for the first line. And next second line, ampersand N is assigned to P. What is ampersand N? Ampersand N is assigned to P, that is called 4000. 4000. Now, ampersand N. What is ampersand N? Now, what is the ampersand? Ampersand is nothing but the address of the variable. N is directly we extract the value from that address. But ampersand N, so address of N equal to, it will return 4000. Now, address of P equal to ampersand P. What is the ampersand P? It return 5000. Now, value of N equal to percentage D N. The value of N. What is the value of N? 10. It will return 10. Now, value of N equal to ampersand 10. What is ampersand 10? 4000. Ampersand 10, 4000. It means this notation, this syntax nothing but ampersand 10, 4000. For the star of 4000. Star of 4000 means value from 4,000. What is the value from 4,000? Then it will also return 10. And value of n equal to star p. Value of n equal to what is the value? 10. So how to extract value? So p equal to ampersand here. Observe here. So the address is there. Both side I want to take the star symbol. Now star p equal to ampersand here. What is already we declared? 4,000. What is the value of the 4,000? Star indicates value, extract the value. Okay, star 4,000. Then it will return. What is star 4,000? Star indicates the value that will return the 10. And value of p equal to what is the value? 4,000. P equal to 4,000. Then this is about the simple program on pointer. Okay, next we will discussing about the pointer to pointer arithmetic. The next concept, pointer arithmetic. See, we know arithmetic operators. Everyone knows the arithmetic operators in our C language. Not only C language, in all languages we have some arithmetic operators are there. That is addition, subtraction, multiplication, and one more is the division, modulo division also. Right now, see pointers in first one where we know the pointer, that is a pointer is a variable which stores the address of another variable. So now we have to declare two normal variables and two pointer variables. Now this normal variable address is assigned to the pointer variable. Normal variable address is assigned to the pointer variable, and we have extract value from the pointer variable, then we use the asterisk symbol, asterisk some value. See now here, C pointer is an address which is a numeric value. Therefore, we can perform arithmetic operations on a pointer just as we can a numeric value. The following operations are: first, how many pointer variables we have? Two pointer variables. How many normal variables we have? Two normal variables. Now directly we are not assign the value to the pointer. So first one, now this address means, see, observe here, this is x and this is y. Now y x address is, we assume 4,000. Now y address is, we assume 4,020. Right. And one more, two variables are there. This is P1, P2. Observe here, P1, P2. Now, the address is P1 5,000. The address is 5,040. We assume. So, this is for the first line. Now, what are the values of x and y? X value is 5, y is 9. Right? And now, pointer is a variable which stores the address of another variable. Now, ampersand x. What do you mean by ampersand x? Ampersand x. X is 5. See, observe here. X is the name of the variable. 5 is the value of the variable. 4,000 is the address of the variable. So, 4,000 is address of the variable. Now, ampersand x, what is the value? 4,000. Ampersand y, what is the value? 4,000 into 20. See, when you are assigned a value, P1 equal to, now x, y 5 is assigned to x. So, the value of x is 5. Now, 4,000 is assigned to P1. Now, what is the value of P1? 4,000. And 4,020 is assigned to P2. So, 4,020 is the value of P2. Now, how we are extract value from value through the P1? See, P1 ampersand x is assigned to P1. Now, both side I want to use the asterisk symbol. Ampersand x. What is ampersand x? 4,000. What is the value of the 4,000? Star is indicate the value. So, what is the value of 4,000? 5. Now, star P1 equal to 5. Star P2 equal to 9. So, what are the arithmetic operators we have? Addition. Right? Addition. Now, how can we add two terms? star P1 plus star P2. Okay, star P1 plus star P2. That is the addition. Now, sometimes we have to use the increment and decrement operators, and right, and now sometimes we have to take the logical relational operators. We have to implement all operators on the pointers. So now I want to take one P1 plus 4. What is the P1? What is the P1? P1 is the address. 4 into size of data type. Size of data type is that is called actual 4. Now 4 into 4, 16. 16 plus 1020, 1036. Here we take the integer data type is 2. That's why 1028. Now P1 minus P2. So P1 we take some value, P2 take some value. Now coming to same operators, assignment operator, increment operator, decrement operator, and a relational operator P1 greater than P2, P1 equal to P2, P1 not equal to P2. We have to implement all the operators on the pointers, right? But direct P1 greater than P2, that is take the addresses only. Now, addresses means other variable addresses. Here we have a al value. If you want the other values with the pointer, then you should take star P1 plus plus. Now, what is P1 value of star P1? Fine. So, star P1 plus plus, that will indicate the now value will be incremented, right? Now, division operator P1 by P2, P1 by 10, P1 into P2, P1 plus P2. Okay, now you apply the right shift, left shift also. So, now this is the small program. Now, I want to explain one program with Dev C++. Here, stopping this slide. Go to the Dev C++. Where is yeah? This is the Dev C++. Now you are implementing pointers. Concept is pointers, right? Hash include stdio.h main method. Okay, now you are declare the variable, same previous program, a comma b comma star p1 comma star p2. Two variables enough. Now we are assigned some value to the variable, or you read the value printf enter a and b values. Scanf percentage, one more percentage, comma ampersand a comma ampersand b. Right? We have two variables now. P1 equal to ampersand A is assigned to P1. Ampersand B is assigned to P2. Well, what is the ampersand A and ampersand B? Address of A, address of B. So now I want to print the printf A equal to percentage B. Take line, comma A. Just I want to copy the statement. And take A, take ampersand A. That is the address of A. Now B ampersand B, this is B. Now this is P1 P1, P2, P2. Now star P1, P1. If you want to print address of P1, then ampersand P1. Use ampersand P1. Star P2, star P2. Right. Print the values. Now I want to print that is the use arithmetic operators star P1 plus star P2. P1 plus star. You are implementing remaining all arithmetic operators. Better you should take the bracket here. Yeah, division. Okay. Yes. Now next one is the modulo operator. We are implementing all the that is also now I want to write like this. Star P1 is it greater than star P2? That is the relational operators we are implementing here. Okay. Next we will see the remaining. First we save this program. Pointers basics. Save as C program. Okay, no error. One second. Yeah. Now I want to execute this program. Stop share. Yeah, I think it is visible. Now A value, you are enter A and B value. A value is 10, B value is 5. A value 10, B value 5, A equal to 10, ampersand A equal to, that is address. Okay, 612. You remember 612? B equal to 5 is assigned to B, ampersand to B. Okay, now we with ampersand value. So P1, the address of P1, because you observe here P1 equal to ampersand A, P2 equal to ampersand B. So 612, and this is the actual B address is the 608. Now star P110, star P2 5. Now star P1 plus star P2 15. Now minus 5, 50 and 2. And here modulo operator, you observe here, modulo operator is not applicable for the pointers, right? So next one is star P1 greater than star P2. Is it satisfied or not? Now what is star P1? Star P1 is the 10. Where is the star P1? 10. Right. Star P2 is 5. 10 is greater than 5. Yes, condition is satisfied. That's why it will return 1. Okay, this is the simple basic program on pointer arithmetic. Yeah. Yeah, now this is the normal program already we covered. This is the program and pointer and arrays. Pointer to arrays, it is very important. Okay, pointer, already you know the definition of pointer. Pointer is a variable which stores the address of the other variable. Now, what is array? Array is nothing but a collection of similar data items. Observe. Array is a collection of similar data items. Now, these all similar data items are held in one variable. That variable is named called array or subscripted variable. Now, coming to here, how declare the arrays? You write them like this. Int a of 10. Observe here. This is the variable declaration. Now, previously, how can you declare for the standard variable? Into a, comma, star p. Same thing is repeated here. Instead of a is a singleton variable. Here, we take the group of elements. So, group of elements is declared as a of 10. Into a of 10, comma, star p. Observe here. Into a of 10, comma, star p. Now, previously, we are used the a equal a ampersand a is assigned to p. Same way we have to assign the base address to the pointer. Base address to the pointer. When an array is declared, the compiler allocates the base address. Observe here, starting address. Now, what is starting address? For example, now starting address is we assume 1002. The starting address is the 1002, and automatically this array is a collection of similar elements. These elements all are reside in sequentially. So what is the next element address? 1004. What is the next element address? 1008. Okay, we continue, right, for the last element. Okay, so there is no need to take a second address, third address, fourth address. Automatically that will increment to by 1. That is the memory representation of an array. So we declare the A of 5, we take some elements or we read some elements. Now these elements, the first element is reside in 0, last element is reside in n minus 1. So now P equal to ampersand A, that means P equal to A, ampersand A, then the base at A is also acceptable, A of 0 is acceptable, ampersand A of 0 is also acceptable. So the base address is assigned to the pointer. So when I value is incremented, then base address is also incremented by 2 or 4. This is the pointers and arithmetic. Now, name of the pointer, name of the array is the starting address of the array in the memory. It is also known as the base address. Already we take A. A is the base address, or ampersand A of 0 is the base address, right? And ampersand, now P equal to A, valid. P equal to ampersand A of 0, that is also valid. Array name A is the same as the address of A of 0, right? This is nothing but this. Now value 0th location. Value at 0th location is observed here, star P, because P equal to A, right? Star P plus I, simply we take the I. I into size of data type. What is the size of data type? For example, 4. I value initially 0. 0 into 4, 0. Base address is that is 4000. 4000. The star of 4000, we extract the 0th element. And I value is incremented by 1. I equal to now 1. I equal to 1. Now P plus 1. 1 into 4. 1 into 4 because internally this is multiplied with the 4 because integer data type size is the 4. Now base address is 4000. 4000 plus 1 into 4. Now 4004. Star of 4004. We get the value from that address. I will show with the example. So here I explained. So this is the, and if you want to take the A of 2, that is nothing but a star A plus 2. I can explain here A of 5. So what do you mean by A of 5? Which allows the 5 elements. 4, 3, 2, 1, 0. A of 0, A of 1, A of 2, A of 3, A of 4. Now addresses I want to take 4000, 4004, 4008, 4012, 4016. See, right. This is enough. And you read some elements. Already you know how to read the array elements. Right? Now I want to take P equal to A star P. This is the P. P. Address is the, that is also variable, so 5000. P equal to A. A means, what do you mean by A? Ampersand A of 0. What is the ampersand A of 0? 4000. Yep, sorry. Link is established. So now I want to read the elements. First, I want to read the elements. For I equal to 0, I less than n value equal to 5, I plus plus, scanf, percentage d, comma, percentage d, comma, p plus I. Observe here. P plus I. What is the base address? 4000. Now 4000 plus I value. I value, what is I value? 0. 0 into size of data type. 0 into size of data type. 4000 plus 0. What is the value? 4000. So first element, for example, I want to enter 6. 6 is reside in 4000. Now I value is updated. I value equal to 1. 1 less than 5. Yes. 4000 plus 1 into, observe here, P plus I means 4000 is the base address. No change. 1 into size of data type. Size of data type is 4. 1 into 4, 4. 4000 plus 4, 4004. The next value is reside in 4004. Suppose I want to enter 1. 4008. Next I value is updated. I equal to 2. Right? I equal to 2. Then 4000 plus 2 into 4, 8. Now we are enter element 7. Some 5. These are the reading of our elements with pointers. Now, how can you print these elements? Same thing is repeated here. For I equal to 0, I less than n, I plus plus, printf percentage 3d star of p plus I. Star of p plus I. It is star of p plus 2 means P is the base address plus 2 into size of data type. Same. P, what is I value? 0. What is P value? 4000. 4000 plus 0 into size of data type. Size of data type 4. Now 0 into 4, 0. 4000 plus 0, 4000. Star of 4000. What is the value of 4000? 6. You print to 6. And I value is updated. I equal to now 1. I equal to 1. 1 less than 5. N. Yes, condition is satisfied. Now, star of P plus I. P plus I means 4000 plus 1 into 4. 4000 plus 1 into 4. Then that will return 4004. You continue until condition fail. Now, here we have a scale factor is there. Now, this is the scale factor. Scale factor means now these are all the declaration is important for so it will return the same value. When we increment or decrement a pointer, its value is increased or decreased by size of the data type that is called P plus IE or star P plus IE. I means here a scale factor I into size of D type. I into size of D type. Now already we discussed I into base address 4000 plus I value 1. Assume I value 1. 1 into 4. It will return 4004. I value 0. 4000 plus 0 into 4. Return 4000. Now I value is updated. Base address is 4000 plus I value is now 2. 2 into 4. So 4008. I value is again updated 4000 plus 3 into 4, 4012. 4000 plus 4 into 4, 4016. So first element is available from 4004, second 4000, second element 4004, third element 4008, fourth element 4012, 4016. This is the scale factor.